Okay. So let's try some set games. So over there, I want people whose hair color is natural. And over here, I want people whose hair color isn't natural. So natural, not natural. Okay, so one thing that we should note is that we have a set over here, right? And a set over there, and together they're everybody, right? We need a word for that. Okay, so if that and that are everything, then this set and that set are called complementary, right? You guys cool with this?
Yeah.
Okay.
This is stats.
Hello, you got it?
So, can I get brown eyes over here, blue eyes over there, and anything else back here?
Blue eyes where?
Brown eyes, blue eyes, everything else in the back.
Blue eyes are down.
They're blue on some days.
Really?
This is actually
That many of you have blue eyes? I believe you.
If I
Okay, so here we have an example of two sets that aren't what? These two sets
They're not complementary?
are not complementary. Why?
Oh,
Because they're not everything.
they're not in here. Yeah.
Because these guys are standing behind the thing. So, what are these two sets? So what's special about this?
they're
They're
independent.
defined by like one variable, like one thing, like one.
Yeah, there's one condition,
Yeah, there you go. Thank
and everybody's in one camp or the other, right? You guys see that? Nobody's trying to split the boundary here.
one blue eye, one.
Yeah, so
Does happen.
what if there was a person who had,
Tetrachromia.
yeah, this thing, different colored eyes. So, where would they try to stand?
Wouldn't they just go to where everything else is?
They're holding hands.
I think they should be in both groups, right?
So it's not a function.
So these two groups right now, as they are disjoint, meaning there's nobody in both camps. You see that? But do two groups always have to be disjoint? No. Okay, so far we've learned complementary and disjoint, right? Okay.
Complementary, whatever you
Preferably not. Okay, so what other conclusions can we draw from this stuff? Why was I surprised by so many?
Because it's a recessive gene.
Yeah, because blue eyes aren't super common. And yet here we have what? A bunch of the class has blue eyes. So what's the relative frequency of blue eyes in our classroom? What does that phrase even mean?
It's half.
Well, it's
they are
most.
literally half of us.
Yeah, so there's 3, 6, 7.
And then 14 in total.
Yeah, so half of the class is blue-eyed, right? So that's what it means by relative frequency, right? You count out how many there are in that group and divide by what? The total. Yeah. So what's the relative frequency of brown-eyed people? 3 and 14. What's the relative frequency of unnatural hair color?
2.
1, 7. And the relative frequency of
Mitch, you got that?
and the relative frequency of natural hair color?
6 or 7.
Okay, so what's special about 2 and 7 or 1 and 7 and 6 and 7?
They had to make one.
Mitch, one's bigger.
Yeah, those two sets were complementary, right? And it's no mistake that their probabilities add to 1. Did I just say probabilities? What the hell is that? Why did I just throw that word in here?
When the entire population is represented as
I'm
one,
trying to confuse
the
you.
relative proportions of the probability.
Yeah, so what I'm saying is in this group, right, if we just closed our eyes and threw a dart into the lot of you, right, whoever got darted would have a Yeah, half of the people we darted at random would have blue eyes, and the other half wouldn't, right? You guys see that?
Can we test it?
Yes, let's test it.